Domain and range are used to describe where a graph lies on a Cartesian plane. Domain is specifically looking at the x-axis. So what are all x values of that particular graph? Range is looking at the y-axis, or what are all of the y values of that particular graph. We know that we can represent a relation in various ways: ordered pairs, equations, table of values, graphs, etc. So another way of saying the x values is just the input into a table of values. It would be the first element in the ordered pair, or it's what we call the independent variable on the x-axis of the graph. Similar with range, we know range is the output. It's that second column on a table of values. It is the second coordinate in an ordered pair, or it is the dependent variable on a graph. In the beginning, one way to remember which is to think domain, D comes before R in the alphabet, just like X comes before Y in the alphabet. So domain goes with X values, whereas range goes with Y values. There are 4 different ways that we use to represent domain and range. One thing you want to remember is that we always need to move from the smallest value to the largest value. So we're going to begin with the smallest and we're going to end with the largest. That's important. The first thing we can do is use words, where we can just verbally write out what are the values that are allowed for that particular graph, or what values on that graph are represented. We can also use a number line, which will give a picture of where the graph is going to lie on each axis. The formal mathematical way that comes up most often as you go forward in math is set notation. So if there's one method you really want to focus on and get good at, this is the one. Set notation is crucial in terms of higher level mathematics. It's a way that no matter where you go in the world, no matter what language is primarily spoken, everybody in the math community understands what those symbols mean. Remember that when we look at a graph, we're going to see either data that is discrete or data that is continuous. If we see discrete data, that's where we just have a bunch of points and there's no connection between them. They're discrete individual data values. We're going to represent the data in a list, and we'll take a look at how to do that in a second. There are only 2 ways that we can show domain and range with discrete data. So one is using a list for set notation. The other is to use a number line, where we say here's just the values where those points are going to be plotted. It doesn't make sense to use words to say here's the graph at 1, 3, 5. That just doesn't make a lot of sense. So we don't do that. And continuous data, this is the one that comes up most frequently. In set notation, we always start with the way that you read this. So I'm going to read this to you the way that you would see it. It's the domain is a set of. So those braces, we say a set of x values, and this vertical line means such that. So domain is a set of x values such that, and then we describe for that particular graph what's happening, and then we close that brace. And we'll do a lot of examples so you can see how this works. This one would say the range of that graph is a set of y values such that, and then we put in here basically our directions where that graph is going. So if the data is discrete, we're either going to list them with those braces, or we're just going to say on the number line, where do they go? If the data is continuous, we're going to use words, we're going to use a number line, or we're going to use set notation, where we set up this whole statement here. The 4th way is interval notation. And again, this will only apply to continuous data. We're looking at where is the interval that graph lies at. Where does it start and where does it stop? And we use specific types of brackets to represent that. If the end value is included, we have that closed point, we use square brackets. If the end value is not included, we have that open circle, then we're going to use round brackets. If we have an arrowhead on the end of the graph indicating that that graph continues indefinitely, we use the infinity symbol to show it goes on forever. And if we use infinity, there's no specific endpoint, so we always pair the infinity symbol with those round brackets. And one final note here, that infinity symbol is used in interval notation. We do not use it in set notation. So the infinity symbol will only show up when we're dealing with interval notation. My first two examples both contain data that's discrete. That's the first thing you want to ask yourself. Is this data that we're given discrete or is it continuous? If it's discrete, remember there are only two ways that we can represent it. We can either use a list or we can use a number line. So in terms of the domain, I'm going to start by taking a look in my first example at the 5 points that I'm given. Remember, we have to go from the smallest value to the largest value. So I know that the domain applies to the x values. I'm going to take a look at all 5 of those x values, and I'm going to say, what is the smallest one? In a list, this is part of set notation where we begin with those brackets. So we say the domain is a set of, and in this case, we're just listing those values. So we're going to say -3 is our smallest one. Then 0 is the next one, and then 1, and then 3, and then 5. And then we're going to close that brace. On a number line, we're basically just taking these values for x and we're saying where on the x-axis are those going to go. So I draw my number line out, and again, we plot those points. We have a value at -3, at 0, at 1, at 3, and at 5. Now we're going to do the range. So we're going to say again for these 5 data points that we're given, we're going to say the range is a set of values, and if it's discrete data, we're just going to list them all out. So we're going to take a look now at the y values. So we've got a 2, a 5, an 8, a 9, and another 9. We're going to say which is the smallest value, and it is the 2, and then it's the 5, and then it's the 8, and there are 2 9s, but we only list 1. So this just says on the y-axis, we're going to have a point at 9. We don't need to know how many points at 9 we have. And then we're going to draw the number line. So I'm going to get you to pause this, draw the number line, and then you can come back in a second. On my number line, we don't need to write every value down. As long as you have a scale that increases by the same amount, plot those data values where they would fall on the number line. My second example is also discrete. We don't have those points connected by a line. So we're going to start with domain. We're going to go on the x-axis and we're going to see where does that graph lie on the x-axis. You're going to have to pay attention to the scale. So if this is 0 and this is -5, we know that a scale goes up evenly. So I know that each of these tick marks represents 1 unit. All right, so for example, I know that this is going to be -2, this is going to be -1, and so on. The easiest way to do domain is because we're looking specifically at where does that graph lie on the x-axis. Sometimes it helps if you can take a line or take your pencil and lie it going up and down. So it's going to run across that x-axis, and we're going to see where do we have those values. So I'm going to take my line here, and we're going to say, okay, we have an x point at -2. We cross the x-axis there at -1. We cross the x-axis there at 0. We cross the x-axis there at +1. And we cross the x-axis there at 2. In terms of the list, we're then going to say the domain is a set of, we know this is a set of x values, so we're going to have an x point at -2, -1, 0, 1, 2. We're separating them by commas, and again, we're going in order from smallest to largest. For this particular graph, I know that I have a value of x at these points, and then you can put those on a number line. In terms of the range, we're looking at what are the y coordinates for my data. So we're going to run up the y-axis, and we're going to say, where do we have y coordinates? This is the first one, and remember, going smallest to largest, so we have a y coordinate at 1. We have a y coordinate at 2, and it helps some people if they take a horizontal line and maybe just run this along here. So we're going from smallest to largest, and we're looking at where are we going to have something at the y value. So there's our first one. So 1, 2, 3, nothing at 4, nothing at 5, something at 6, and something at 7. So then we can write these in for the range. So I know that this graph will have a y coordinate at 1, at 2, at 3, at 6, and at 7. And then again, you can draw the number line that would correspond to that. With these number lines, if I were to take my domain number line to lie it on the x-axis, we can see those are the points at which we're going to have x coordinates. And then if we take the range number line, if you imagine if rotate at 90 degrees counterclockwise, so it lies on the y-axis. Again, these are the points where we're going to have y coordinates. So we're going to have something here, 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 and then up to 6 and up to 7. So it's a visual way of seeing where will the graph lie on those axes. My third graph shows continuous data, so I now have 4 ways that I need to represent the domain and range: words and number lines, set notation, and interval notation. I'm going to start with domain. So again, I'm looking to see where on the x-axis does that graph lie, and I can see that I now have an arrowhead. So that means this graph is going to continue in theory to negative infinity, and it's going to continue in theory to positive infinity this way. So in terms of the x-axis, I can see that it's going to widen out as we go along here. So it's going to go all the way to negative infinity, and it's going to go all the way to positive infinity. So this graph is going to lie on every x value along that x-axis. So for the domain, we say it is going to be all real numbers. And then because it's every number, what we're going to do for the number line is we're basically just going to show it's going all the way to negative infinity and it's going all the way to positive infinity. So you can just kind of put that over top, or you could even put that right on the line if you wanted. Actually, maybe let's do that. I'll move it down a little bit. So on our number line, we're going to be going all the way from negative infinity to positive infinity. Now, in terms of set notation, we're going to say the domain is a set of x values such that, and then what we're doing is we're basically taking what we put in words and we're going to write that in symbolic notation. So we're going to say x is an element of the real number system. We use a double-sticked R to differentiate real number system from range. And this is kind of looks like an E, but it's a rounded back. It means is an element of. So X is an element of the real number system. And then because we have an arrowhead, we're going to negative infinity. That is not a definite point. So with interval notation, we're going to use a round bracket. We're going to put in negative infinity. And then on this side, we're going to be going all the way to positive infinity, which again is not a definite point. So I'm going to have comma, positive infinity, and again, another round bracket. I think in your textbook, they don't actually use a negative infinity, but we can put the negative infinity in there. All right, now in terms of the range, again, you're going to look on the y-axis. So where is the first y coordinate that we're going to have? Right there. So when y is 0, that's our first point, and it's going to continue up to positive infinity because it's going to keep rising due to that arrow. So in this case, when we go to write this in words, we're going to say it is all real numbers greater than or equal to 0. And we need to include that equal to 0 because there is a point here where y is 0. In terms of a number line, I'm just going to say, let's say this is 0. Because we're including 0, we're going to have a closed dot, and then we're going to show it's going to be all numbers greater than 0. So I'm going to put it like that. In set notation now, we're going to say the range is a set of y values such that, and again, you're basically taking what we wrote here and you're putting this into symbolic notation. So we're going to say y is greater than or equal to 0, and y is an element of the real number system. In previous years, sometimes they tell you these are alligator mouths and they're eating the bigger number. These are actually the ends of the number line. So this is pointing to the numbers on the number line that are getting bigger. So this is your greater than symbol. This one is pointing to numbers on the number line that are getting smaller. So that is your less than symbol. Now, if we go along the y-axis, our smallest value for y is that 0. That is a definite point that's included. So because we're including that point, we want a square bracket and a 0. And because our maximum point or our highest value for y is going to be infinity, that is not a precise point. So we're going to have infinity with a round bracket. And again, remember, we always have to go from the smallest value to the largest value when we're setting these up. My computer somewhat erased this, but just make sure on this number line here, we do want a closed circle because we are including that y value of 0 there. Okay, example number 4 is also continuous data. So there's going to be 4 ways that we represent this. The first thing we want to do is identify where is the domain going to go. And if you take a look at this graph, we can see that it looks like we are including this value, and it looks like we are including this value. Whereas if you look on the y, you can see on the y-axis here, we're not quite touching that line, so that's not going to be included. And then we're not quite touching the line here either, so that's not going to be included there. Again, you have to take a look at your scale. If this is -5, this is going to be -4 because we still have a scale of 1 on the x-axis. This is going to be +2. And then on the y-axis, again, pay attention to the scale. This here is -3. This here is going to be +3. If it helps you to take your lines, on the x-axis, we want a vertical line because we're going to run that line along there. So you might even want to just take your line here and say, okay, on the x-axis, -4 is the first value for x we're going to hit. And we're including every value of x along here until we get to that +2. So when I run my line along here, that graph is touching my line the whole way from that -4 to +2. And then on the y-axis, we can also see if we take a line and run this along here, the first y value that we have, we're going to cross that y-axis there, almost at -3. We're including, our graph is touching every y value up here, and then it's almost going to be at +3. So now we're going to fill this in. So for the domain, our graph is including all real numbers between -4 and 2 inclusive. So that means we are including every number from -4 to +2 on the x-axis. And then the number line just reflects that. We're going to use closed circles to show that we are including that -4. We are including that +2. Graph is going to lie on every value in between those two. And then I'm going to skip down here to set notation. So we start by saying the domain is a set of x such that. Now, we're going to turn what we had in words into the mathematical symbolic notation. So when we have a graph that lies between two numbers specifically, we're always going to begin with the smallest value. We're going to end with the largest one. The variable goes in the middle, and your arrows always point to the left, because if you read this in pieces, this first piece says x is greater than or equal to -4. If we just take this piece here, and this piece here says x is less than or equal to +2. So we combine those into one statement. This says x is greater than or equal to -4, x is less than or equal to +2, and x is an element of the real number system. And then if you compare your number line to this interval notation, you can see we are including that -4. Hence, we have a square bracket. We are including that +2, so we have the square bracket. And again, you have to make sure smallest number, largest number, smallest number, largest number. It has to go in that order. The same thing with the range, except for the difference is we're now not including those values. So I'm just going to say for the words, the range is all real numbers between -3 and 3. We're not including those two numbers, but our graph will lie on every number in between there. I'm using open circles to show that we're not including -3 and we're not including +3. But we are including every number in between there. So when we go to do the set notation, we're going to start with range is a set of y values such that. This now says y is greater than -3. We are not including that equal sign there. So just y is greater than -3 and y is less than +3. And again, y is an element of the real number system. We pretty much always tack that onto the end. And then in terms of your interval notation, because this is an open circle, we're not including -3. We use a round bracket to show that value is not included. And then our highest point is going to be +3. And again, that's not included. So we use a round bracket to show that value is not included there. In our next example, we also have continuous data, so we're going to use all four methods to represent the domain and range. The first thing we're going to do is figure out what is the domain. So where does that graph lie in terms of the x values? It might help you again to take your pencil and put it going vertically. So we're going to run our pencil going from smallest to largest along the x-axis. We still have a scale of 1, we can tell. So our first x value is that -6, that's going to be, and it is included because it's a closed circle. We're also including all of these values along here. My graph is touching my line all the way along, and we're going to get to this point here that's not included, but if you go up, you can see that is crossing where the x-axis would be at 3. So our domain, we're going from -6 all along here to +3. In terms of the range, we're going to see where are we going on the y-axis. So again, we want to go from smallest to largest. So I'm going to start going up. So we're going to touch the y-axis there at -4. That point is not included because it's an open circle. Our graph is included on every point along here until we get to that value there, which is going to cross the y-axis at 5. So y is going to not include -4. It's going to be every value greater than -4 up to and including that 5. Another tip that sometimes helps people to identify in the beginning where the domain and range lie is to actually take some colored paper and put it on the graph to kind of block off where is your graph going. And then once we've done that, we can see, okay, so my graph is going to start, my minimum value on the x-axis is going to be that -6, and then my graph is going to end here, and I can see that's going to be the 3 on the x-axis. You can then do the same thing on the y-axis. Take your paper and put it at the start and the end of your graph, and then going from smallest to largest, now we can see, okay, move over to the y-axis. We can see that -4 is going to be our lowest point, and then go up here, and we can see the graph ends there, scoot over to the y-axis, and we can see that +5 on the y-axis will be our highest point. So to turn that statement into words, we're going to say the domain is all real numbers between -6 and 3, including -6 because of that closed dot, not including 3 because of that open dot. So on the number line, a closed dot to show we are including -6, an open circle to say that we are not including 3. We're going to include all values up to that point. In terms of the set notation for domain, we say the domain is a set of x such that x is greater than or equal to -6, x is less than 3, and again, we're not including it, so there's no equal sign there, and x is an element of the real number system. -6 is included, so we use a square bracket. +3 is not included, so we use a round bracket. With the range, we say all real numbers between -4 and 5. So now we're not including -4, but we are including +5 up here. And you can see why mathematicians prefer set notation, because this is quite tedious when we write this out too many times. So this is the much faster way. The range is a set of y such that y is greater than -4 because it's not included. We don't have that equal sign there. We also use an open circle on the number line. We use a round bracket on interval notation. Y is less than or equal to -5, so we use a closed circle to show, or sorry, that should be +5. Let's change that. So y is less than or equal to +5. So we're going to have a closed circle to show +5 is included, and a square bracket to show that we are including +5. And then remember, if you take this number line and put it over top of the x-axis, you should be able to go straight up on -6 and see a closed circle, straight up on 3 and see an open circle. So here's -6, there is our open closed circle, and then here is 3, and in this case we go down, and there's that circle. Same thing with the range. If you were to take this and put that number line vertically on the y-axis, we should be able on the y to go right over there at -4 and see something, and then right up there at +5, go over and see that dot represented there. 2 more to go. How are we doing so far? We're getting there. Each one of these is slightly different, so that's why we're doing a variety, just to see all of the different scenarios you may be encountering. 6 again is continuous data. First thing we want to do is pick out where is the domain going. So if we take our line, and you can take your pencil or however you want to do it, but we can see that the first value we're going to hit on that x-axis is -2, and our graph is going to continue forever because of that arrowhead there. So on this graph, we're having all values of x that are greater than -2 up to positive infinity. On our y-axis, again, you might want to take your line here and say, okay, on our y-axis, we are starting there at -3. We're not including that, but our range is going to be all values of y greater than -3. And again, that's going to continue going up to infinity. So I want you to see if you are able to turn that into words and a number line. You can stop at the notation part and then pause this video, come back and see how you did with that. So in terms of the words, Our graph lies on all real numbers greater than -2. We are not including -2, so that's hence we have greater than -2, and we also have that open circle to show it's going to be every number greater than that. And then in terms of set notation, we have the domain is a set of x such that x is greater than -2. Because we're not in between two values, we just begin with the variable and then have the greater than symbol not equal to and then -2, and x is an element of the real number system, close the brace. We are not including -2. We're going up to infinity, which is also not a definite point, hence we use round brackets for both of those values. Our range is all real numbers greater than -3. That's how we represent it on the number line. And because it's very similar to the set and interval notation for domain, I want you to actually try this. Grab some paper, and I want you to practice writing it out. As you practice more and more of these, you will just become familiar with those symbols. The range is a set of y values such that y is greater than -3 and y is an element of the real number system. We use round brackets. -3 is the smallest value, and we go to infinity, which is our largest value. Again, not a specific point, so we use the round bracket. And that brings us to number 7. All right, domain in this case. Now this one's a little bit different because you can see this point here is not included. But if we go straight down here, when x is 0, that point is included. So even though this isn't included, this one is included. So our domain is going to begin on the x-axis at 0. And again, if you take your line, we can run this across here. We can see that it's going to stop at that 5. So our domain is going to be from 0 to 5. And then our range is going to run from 2 up to that 7 there. I'm going to get you to pause the video and try this because the more that you start to write this out, the better you're going to get at it. So if you make mistakes, that's okay, we can fix them. But pause the video, grab some scrap paper, you try writing this out, and we'll see how you did here. Okay, so with the domain, we have all real numbers between 0 and 5 inclusive. We are including the 0 when x is 0. We're also including when x is 5. So we have closed dots on the number line for both of those. And then because they're included, we have square brackets on interval notation. And again, the domain is a set of x such that x is between 0 and 5. Both of those values are included, so we have the symbols with the equal sign in there as well. Our range is all real numbers between 2 and 7. Now this time we are including 2. We are not including 7. So 2 is included, 7 is not, so we have the open circle. And again, on interval notation, square bracket, 2 is included, round bracket, 7 is not included. And make sure that you went from the smallest value to the largest value. And then also make sure with your set notation, we are including 2, so y is equal to 2 or greater than 2, and y is less than 7. It's not equal to 7, so make sure you did not put that line there for that one. Final question we're going to look at today is an application problem where you can start to see how domain and range are going to be used. The first thing you always want to do is identify what are the two things we're comparing, and the units will often give you a clue. So we can see in this question, centimeters is a unit of length and seconds is a unit of time. Time will be the independent variable. So I drew my sketch down here, and because this is seconds, I actually changed this. So it should be time in seconds, and this is the height in centimeters. So it's going to be kind of a miniature model of a Ferris wheel. We have some kind of a base 3 centimeters high off the ground that the wheel is then supported on. And again, this is not drawn to scale. Because the radius is 22 centimeters, I drew my radius from the center of the circle going straight down so that I can see if this is 22 centimeters, this is going to be another 22 centimeters. That means my diameter is 44 centimeters. Plus another 3 centimeters means that from the base, this highest point on the Ferris wheel is going to be 47 centimeters. So I'm going to go over here and put that in for A. So this is going to be 47 centimeters. And I also know that the bottom of my Ferris wheel is going to be 3 centimeters off the ground. So I can go over to my y-axis and fill that in for my B value. Now, it tells us that it takes 10 seconds to complete one revolution. So, assuming we get on at the bottom, we're going to go up to the highest point, and then we're going to come down. That's one rotation around. So if I get on at the lowest point B, my Ferris wheel, so this is time. So as time is passing, I'm going to go up off the ground to the highest point, and I'm going to come back down. At this point in time, my second rotation is going to begin. So that's how I know at 10 seconds I've completed one revolution. So then I'm going to go up to the highest point, and I'm going to come down again. This is going to take me another 10 seconds to complete that rotation. So I know that this is going to be 20 seconds later. So when we're looking at the values of A, B, C, and D, we've already identified that A is going to be 47, B is going to be 3, and D is going to be 20. I want to do that even before I know what the question's asking. C is going to be 0 if B happens to be 3 off the ground. So we can put here, this is going to be 0. Time is beginning at 0, and height is also starting at 0. That's the origin of our graph. This, by the way, is a sinusoidal function. In grade 10, we deal with linear functions. In grade 12, we're going to get to sinusoidal functions. So think sine, one of your primary trigonometric ratios. We're going to start to tie this all together in the coming years. In terms of the domain and the range, I'm not going to do all 4 forms because it's going to be a little time consuming and you've already sat here for a long time. But set notation is the most crucial one. So for this particular graph, my domain is represented on the x-axis. So if you want to use x as the variable, that's okay. But what we're going to do eventually is we're going to start to say, what is the x-axis representing? And in this case, it's time. So for this graph that we've shown, if we start at 0 and if we end at 20, I'm going to say my domain on this graph is a set of time where time is greater than or equal to 0 and time is less than or equal to 20, and time is an element of the real number system. The range in this case represents height. So I'm going to say my range on this graph is a set of h values such that my height is greater than or equal to 3, my height is less than or equal to 47, and again, my height happens to be an element of the real number system. So this is where you're going to start to use your domain and range skills, and we're eventually going to apply this to almost every graph we do. It's going to be the directions as to where that graph lies. I did decide to go back here and put interval notation in here. Set notation, hands down, is the one you want to focus on. The whole time you go through this, that's the one you want to get really good at. Interval notation, however, does come up in calculus. So we don't so much use it in grade 11 or 12, but when you get into calculus, we do start to use interval notation a lot with the brackets. So if there's 2 that you absolutely want to get good at, it's set notation number 1, interval notation number 2.